All right, so we'll get ready to begin. We at the Lyme Monitor team are extremely proud of all that we've accomplished this capstone. As you're familiar, this is our team of experts, the core team, domain experts from the University of Montreal and from previous cohorts, and of course the Harvard team. We have a packed agenda today. First, I'm going to talk about some background and our achievements. Next, we're going to move into data discovery, model development, data pipelining, and visualization. And finally, we are going to discuss our challenges, potential future work, and leave some time for Q&A. As you're aware, Lyme disease is a tick-borne illness that is currently on the rise in the United States. Early diagnosis is important because chronic Lyme is a serious condition with major health, societal, and economic impacts. At a high level, our project can be broken down into 4 components: data discovery and processing, modeling, data pipeline design, and data visualization. We accomplished a lot, but we would like to highlight the following 3 achievements. Our extensible data agnostic pipeline, which is invaluable in today's shifting data availability landscape. Our real-time dashboard that plugs into the pipeline to display social media, Lyme disease hotspots. Our NLP and LLM models that automate the arduous job of labeling vast quantities of data manually. And now I'd like to pass it over to Lakshmi to talk about data discovery.
Thanks, Sheraz. Next slide, please. So as part of phase 1 of our data discovery, it involved acquiring the social media data via the RESTful APIs, then applying Lyme disease related keyword filters that was provided by our sponsor, labeling. So we selected 3 labels: diagnosed with Lyme, indicating that an individual was diagnosed with Lyme; related to Lyme, text that discusses about Lyme disease; and not related to Lyme, and that has no connection with the Lyme disease; and determining the geolocation using certain techniques. So in case of Reddit data, we could apply those techniques only if the user had mentioned the geolocation in the text. Then phase 2 entailed classification using NLP classifiers and data aggregation with weather information that is obtained from the Meteomatics weather time series API using the geolocation and date time that is sourced from the social media text. Next. So we explored both discriminative as well as generative models. Next. So in our table over here, you see that we explored several bird-derived fine-tuned models for text classification. And you will see that we used bird tweet base as the baseline model because that was used by our previous cohort. And we could use it to see, we could compare that in relation to other models. And distilled bird base uncased was used in our pipeline, because of the model size that you see, and secondly, because of the it performed well. And you can see that in our subsequent slide where we showcase the metrics. Next slide, please. So this showcases the performance metrics of all the NLP models that was trained and tested on Twitter data. So looking at the F1 scores over here, the first 2 models, if you see, the distilled bird base uncased and the Twitter Roberta-based sentiment model, slightly outperformed the bird tweet model, which was our baseline model. And for the training, we use the previous cohort's training data. If you look at the confusion metrics, there are few misclassifications. Most of the data are classified as related to Lyme and not related to Lyme. So we had very few diagnosed with Lyme records, so pretty imbalanced data. Next. So this slide shows the performance metrics of the NLP models that was trained on Twitter and tested on unseen Reddit data. So if you look at the scores, the average score was anywhere between 50 to 55%. So this performance was expected since most of the Reddit posts, if you see, they are long paragraphs, and Twitter, the tweets are just one-liner text. And also in this case, the model passed a maximum length of 100 tokens. And if you look at the confusion metrics over here, you will see that there is very high misclassification between related to Lyme and diagnosed with Lyme cases. And that actually affected the overall accuracy. So it was challenging even for us to distinguish between the two labels and label them correctly. Now over to Kislay for the generative AI models.
Thank you, Lakshmi. Next, please. As Lakshmi explained earlier, right? So first we started with the discriminative AI, and then we thought that we should use generative AI models given the recent popularity of these models. And the very first thing for us was to decide what infrastructure we should use, because all these models requires highly efficient GPUs. We started with Hugging Face endpoint, but that did not work well. Then we got into Google Colab and AWS, and we decided that we'll use these two platforms as our infrastructure platform. Then next section was that what model we should choose. There are numerous models available in LLM space, and we chose Llama 2 for Meta and Cloud Instant from Anthropic for our modeling exercise. Now, once model selection was done, we had to test these models. So we started with few shot learning approach because that doesn't require any training. And we used 3 shot learning because we had 3 different classes, as Lakshmi explained earlier. And we got decent results. But next step for us was to fine tune these models. So specifically for Llama 2, we thought that we'll do fine tuning, but that requires good golden truth label. We did not have that for ready data. So what we did as a team, we selected a sample of ready text, and individually we labeled each and every record. And then we used voting mechanism to decide the final label to avoid any observer bias. And once we had those golden truth level available, even it was less in volume, we used that for fine tuning exercise. We use parameter efficient fine tuning technique to fine tune the Llama 2 model. And once we had fine tuned Llama 2 and foundation model of Cloud Instant, we just came up with multiple prompts, creative prompts as a team, and we choose the one that provided us the best performance. Next, please. This is the LLM performance metrics. You can see here that LLM has performed better on Twitter data compared to Reddit, and Llama 2 has slightly better performance compared to Cloud Instant, and that was for obvious reason because Llama 2 was fine-tuned on these texts, but Cloud Instant was a foundation model. Now, when we compare the performance on Reddit data, none of these models has performed well. And as I explained earlier by Lakshmi, we felt that these LLMs has difficulties in distinguishing between 2 levels specifically. One was related to Lyme and another was diagnosed with Lyme, because Reddit texts were very similar for these 2 classes. Next, please. And this is our final performance comparison. We chose Distilbert in our pipeline. If you see here that it has slightly outperformed than LLMs, both the LLMs on Twitter data. And Llama 2 fine-tuned version is quite comparable to Distilbert, but we chose Distilbert as our final one because of like less complexities and all. But if you check the result on Reddit data, none of these models has performed well, but LLM are slightly better. So we believe that if we have good volume of good quality ground truth label, and if we use that for tuning all these models, performance on Reddit text will be better for sure. Now I will hand over that to Rafa to explain data pipeline.
The data pipeline. Our objective for our data pipeline was to create a source-agnostic pipeline capable of streaming data in real time. This is the logical architecture diagram of our pipeline. On the left, you can see multiple Python programs that run in parallel and obtain the data in 2 phases. On phase 1, we use RESTful APIs to obtain the data from the social media sources. And if the geolocation data is not present, then we use multiple techniques to approximate the geolocation. On the phase 2, using the geolocation and the datetime of the event, we enhance the data, getting the events were data. Then we apply our prediction model to obtain the text classification labels. We use multiple Kafka topics in parallel to stream the data to Logstash. Logstash standardize the data and provide the data to our Elasticsearch database. From there, using Kibana, we graphically analyze the data in our early warning dashboard. In order to isolate the environments from our multiple tools, and also to facilitate redeploy or resize the application to a different or bigger server, we orchestrated our application using containers. And we created 3 main containers. The first one for the Python environment, the APIs, and the models. The second one for streaming, for Kafka, Zookeeper, and brokers. And the third one for the Elastic Logstash Kibana environment. The early warning dashboard. This screen is the data discovery. It's a snapshot of 24 hours of data. Here we can see how the data is flowing from our data social media sources. And the data shares similar structures from all the sources. On top, you can see a histogram that shows the counts per hour, and it's also color-coded by the social media source, in this case, Twitter and Reddit. And finally, this is our dashboard. On top, you will notice that we added multiple filters related to the main data fields from our structure. That allows to search using multiple combination of variables beyond the Kibana native filters. On the left, we have the main pane, which is the world map. Here we show every event with a green dot in its location. We also have a view with a heat map that highlights the points with higher incidence or closest locations using colors. On the right, we have 2 graphs. On the top, we have a histogram showing the last 2 days. And it's also color-coded using the text classification labels. If we hover over the bars with the mouse, we can see the detailed counts per label. Below, we have a pie chart that shows the top 10 cities with events. It's also color-coded by our classification labels. And similarly, if we hover over the splits with the mouse, we can see the detailed counts and percentages. And finally, on the bottom of the dashboard, we show the top 5 texts from the latest events. As I mentioned before, we can search using multiple combinations of variables to filter. For example, the social media sources, the classification labels. You can see also the counts next to the text, the cities, the states or countries. Or we can also define ranges of values to include within the filter the weather information like temperature, precipitation, pressure, wind, etc. Now, Temi will talk about our challenges and solutions.
Thank you, Rafa. So just like any other project, when we sign up for this, we expected challenges, which is normal. However, we didn't expect that the most important part of the project will be our challenge, which is data. Access to data and restriction was the major headwinds to this project. However, the team is a very solid, amazing group of individuals. So the goal here is we face challenges. How did we solve it? So what you see here is just a brief snapshot of the challenges we face. So starting with Twitter restriction of their API for academic purposes. We solved it by paying monthly for a 10,000 tweets for $100 a month. That leads to another restriction because $10,000 tweet is very restrictive to what we intend to achieve. However, we solve this by utilizing past cohorts data pool in our training. Also, tweets and Reddit posts, in most cases, don't have geolocation. We need this because we wanted to be able to identify locations based on hotspots. We fix this by employing some advanced techniques in order to determine geolocation on those tweets and Reddit. And finally, our team went down a very interesting path, which is opening the door into Meta. Facebook is a very unique component when it comes to data. Most of the age group that we really want to pull data from do use Facebook. Thereby, the team spent a lot of time basically knocking on all doors possible to get access into Facebook data. We did. Right now, we're only waiting on just one signature from the Harvard OSP office. And our team has finally decided that we are still continuing to knock on that door until we have access. What I can tell you is this: imagine the dashboard you just seen, which is, of course, Twitter and Reddit. But as Rafa mentioned, and the team has been mentioning, this is data agnostic pipeline. Imagine plugging Facebook data into that dashboard. What you will see will amaze you, which leads to another slide here for us. Next. How do we move the needle? How do we take this from here forward? We inherited an amazing group of cohorts that have been working on these projects. And we wanted to make sure we contribute meaningfully, and also we pass down the baton to the next cohorts. So they can launch right now the dashboard because it's running on localhost. We believe based on what we have, they'll be able to pull that through and launch it and make it live. With what we've done, all the works we've done in knocking or basically breaking the barrier of getting into Facebook data, they'll be able to easily springboard themselves and get access into that data. We strongly advise them to curate high quality data from industry experts for fine tuning. Also, we advise them as well to look into using advanced platforms such as Amazon Bedrock for their fine-tuning processes. Finally, very importantly, a lot of us didn't know we were going to see this, but we did. While we were manually and due to the project, labeling some of these data, Reddit stood out to us. We didn't expect that because when you look at tweets have limitations. A lot of them not so good, but Reddit was a lot. What we discover is identifying a lot of information that people are posting on Reddit. Some of them are very deep. Sometimes a lot of us needs to go listen to some nice music just to clear our brain from some of the things we read. Lyme disease is a debilitating disease. And we, the entire group, went through that process. What we also saw in the data, there's some health information, medication, outcome, some chronic behaviors and outcome that people have seen exist in Reddit data. So we believe that the future cohorts could actually use this and identify some health insights and be able to move the needle forward for Lyme disease and for some other diseases, either that exist today or that will exist in the future. Next slide, please. At this point, we really appreciate you guys for taking the time to listen to us, and we are willing to answer all of your questions. Please, thank you.
Well, this is really a great amount of work, and it's just remarkably good results. And I have to agree, building this pipeline to integrate different types of social media is a pretty major step in terms of moving towards something that could be a production quality system here. So this is really great work, everybody.
Thank you, Steve.
Okay.
Yeah.